Hi there and welcome to the channel Cambridge Advanced Level Mathematics here. In this video we would like to solve simultaneous equations using the two methods. One, method of substitution. Two, method of elimination. Without wasting time, let's get busy with it. I'll write the set of equations over here and then I will show you what the method of elimination or substitution, first of all, is all about. Hi there and welcome to the channel Cambridge Advanced Level Mathematics. In this video today we would like to solve simultaneous equations using both of these methods, the method of substitution and the method of elimination. I do have two equations on the board there, and I've labeled them equation number 1 and equation number 2. So we're going to solve this set of equations, first of all using the method of substitution, and secondly using the method of elimination. But first let's write the equations over here where we are going to perform the working. So it's 3x plus 5y minus 7 is equal to 0. We call this equation number 1. Then we have 4x minus 3y minus 19 is equal to 0. And this is equation number 2. Now the idea behind the method of substitution is that we have here two equations in both x and y, and we wanted to reduce these two equations into one equation in one variable, either our x or our y. So in order to do that, you take one of the equations, either equation number 2 or equation number 1, and you express one of the variables in terms of the other. For example, let's take equation number 1. I'll rewrite it over here. So we have 3x plus 5y minus 7 is equal to 0. We want to express x in terms of y. In other words, we want to leave x on one side and everything else on the other side. So first of all, let's transfer our 7 to this side. So we will have 3x plus 5y is equal to 7. Remember, this is a minus 7. When it crosses the equal sign, it becomes a plus. So that's step number 1. Step number 2, let's take our 5y to the right-hand side again. So we will have 3x is equal to 7 minus 5y. Remember, this is a plus 5y. When it crosses the equal sign, it becomes a minus. Now, the last step that's left now is to divide everything by 3 so that we are left with a single x on one side. So we will have x is equal to 7 minus 5y, all divided by 3. Now we have managed to express x in terms of y. In other words, we left x on one side and everything is on the other side. There was no problem if we had chosen y. We could choose y. We could even have used that in equation 2. It doesn't really make any difference. But here we are now, our x is expressed in terms of y. This we did using equation number 1. The next step now is to go to equation number 2, and instead of writing x, you are going to substitute it by this. That's why it's called the method of substitution. So let's do that. Let's go to equation number 2. Here is our equation number 2. It says 4x minus 3y minus 19 is equal to 0. Okay? Now, we now know that x is equal to 7 minus 5y divided by 3. So instead of writing x here, we are going to substitute it for this. So I will write 4 brackets 7 minus 5y divided by 3 minus this 3y minus this 19 is equal to 0. Now, can you see now we no longer have an x in this equation that we have formed. Everything now is in terms of y. Now, we do have a fraction here, and I hate fractions. How are we going to get rid of this fraction? Let's multiply everything by 3. So I will have 4 bracket 7 minus 5y. I'm multiplying everything by 3 minus 3 times 3 becomes 9y minus 19 times 3, it's 30 plus 27, which is 57, is equal to 0 times 3 is still 0. Remember, I'm trying to get rid of this fraction, so I'm multiplying everything by 3. This 3 times 3 gives me a 9. 19 by 3 gives me a minus 57. Let's open the brackets here. We have 4 times 7 is 28. 4 times minus 5, it's minus 20y. And of course, we have this 9y. And we have that minus 57, which is equal to 0. We can simplify. 28, minus 57 plus 28 gives us what? 17 minus 8 is 9. 5 minus 3 is 2. It's a minus because this 57 is minus. Then, of course, here we have a minus 20. Minus 9 gives me a minus 29y is equal to 0. Let's take the 29, the minus 29 to that side. It becomes positive when it crosses the equal sign. So here on the left hand side, we're left with a minus 29y is equal to 29. Now, if minus 29y is equal to 29, surely y is equal to minus 1. So that's the value of our y. Let's just circle it nicely in red. That's the value of my y. Now, if y is equal to minus 1, we have established that x is equal to 7 minus y divided by 3. Where can I write that? Let's remove this. Okay, so remember we said here that x is equal to 7 minus 5y all over 3. This is equal to 7 minus 5 multiplied by minus 1 divided by 3. That gives us 7. 5 times minus 5 times minus 1 gives us a 5. So it's a 7 plus a 5 divided by 3, which is equal to 12 divided by 3, and that's equal to a 4. So x is equal to 4. All right, so there is our value for x. Maybe let's book those results here, because we're now going to use the method of elimination. So we found that here, I hope I don't block your view. I'll write them here. So x is equal to 4, y is equal to minus 1. So here are our results. We want to check them when we use the other method, which is the method of elimination. But just to summarize, the method of substitution, you take one of the equations, you express one of the variables, either your x or your y, in terms of the other. Then whatever expression you get for that variable, you substitute it for that variable. In our case here, we made x the subject, we expressed everything in terms of y, and we left with, and then we came down here, substituted that value of x, and we were left with an equation in y only. And from there, we got here. Once we get here, we go back to our expression, which we found for the x here, and we substitute the y, and we get that. That is the method of substitution. Okay, so let's see what the method of elimination is going to give us. Let's clear all this. We are surely done with it. Method of elimination. The idea is still the same. You want to create an equation, a single equation out of two equations, a single equation in one variable. So let's rewrite our equations here. 3x plus 5y minus 7 is equal to 0, equation number 1. The other one is 4x minus 3y minus 19 is equal to 0. That's equation number 2. Right. Now, in the method of elimination, you look at one of the variables. I don't want to repeat to use x this time because you think maybe there's something. We are going to eliminate y from these two sets of equations. So what we do is we look at the coefficient of y in the first equation. It is 5. We look at the coefficient of y in the second equation is equal to 3. So we try and find a multiple of both 3 and 5 such that when we multiply the first equation by a certain factor and the second equation by the second factor to give us that multiple, we can add the two or subtract one equation from the other and eliminate y. That sounds difficult to explain. Let's do it in practice. So here is a 5y and here is a minus 3y. I'm going to multiply the first equation by 3 so that I have a plus 15y here. And then I'm going to multiply the second equation by a 5 so that I actually get a minus 15 here. And when I add the two new equations to each other, the y just disappears. Let's do that. Multiply this one by 3. Multiply this one by 5. Okay, what happens? So I will have 3 times 3 is 9x. 5y times 3 gives me a plus 15y. Minus 7 times 3 gives me a minus 21. And of course, 0 times 3 just gives me 0. Okay, so I'm done with the first equation. So I'll call this equation 3. Now, I'm going to multiply this one now by 5 to get 5 times 4 is 20x. Minus 3 times 5 is minus 15y. Minus 19 times 5 gives me a 50 plus 45, which is a 95. It's minus 95, is that right? 50 plus 4, yes, minus 95. And this again is equal to 0. Let's call this equation number 4. Now look now, if we add equation 3 to equation 4, what happens? I will get 9x plus 20, it's 29x. 15 plus minus 15 is 0. Minus 21 plus 95, minus 95 gives me, what does it give? Minus 21 minus 25 gives me 1 plus 5 is a 6. 2 and a 9 gives me 11. So it's 116. And here I get a 0. I have created equation number 5, which has destroyed y and left me with an x. So if 29x is equal to 116, 29x minus 116 is equal to 0, that means 29x is equal to 116, and x is equal to 116 divided by 29. How many times? Is it 4? Let's see. 29 times 4, that's 80 plus 36, which is actually 4. Yes. Okay, like we got in the first method there. So we have found x is equal to 4. If x is equal to 4, what is y? We then go back to any one of these equations and substitute 4 for x. So let's take the first one. We have 3x plus 5y minus 7 is equal to 0. So x is equal to 4. So we have 3 times 4, which is 12, plus 5y minus 7 is equal to 0. 12 minus 7 is 5. So it's 5y plus 5 is equal to 0. 12 minus 7 is 5. So if 5y plus 5 is equal to 0, what is y? We have 5y is equal to minus 5. Y is equal to minus 1, as we found previously. Let's recap what we did here. With the method of elimination, you look at your coefficients. We could have looked at the coefficient of x. We could have said, let's get rid of x. If we were going to do that, we want to make the coefficient of x in the first equation equal to the coefficient of x in the other equation. Here, we would multiply x by 4 to get a 12. And to get the same 12 here, we would have to multiply this equation by 3. But in our case, we got rid of y. So what we did was, we wanted to make the coefficient of y here equal to the coefficient of y here. So 15 will do for both of them. So 5 goes 3 times into 15. So I multiply this whole thing by 3. 3 goes 5 times into 15. So I multiplied all this by 5. So that I have a 15 here and a minus 15 here. And when I add the 2, the y disappears. Okay? So those are the two methods of elimination and substitution. In my next video, I am going to deal with the method of matrices for using a 2 by 2 matrix, because we can write this whole system as a matrix equation, and from there we can proceed to